Hello students. Now we are going to discuss a question from electric charges and fields, which is 2 point charges of charge value capital Q and small q are placed at distances small x and x by 2 respectively from a third charge of value 4q. All charges being in the same straight line, calculate the magnitude and nature of the charge capital Q such that the net force experienced by charge small q is 0. So, according to the question, if we draw the diagram, we have a 4q charge here at position A. From this 4q charge, we have two charges placed at distances x by 2 is small q placed, and at a distance x is where capital Q is placed. Now, what the question they are asking is, what should be the value of what should be the value of small q here in such a way that what you are supposed to ask is in this question, uh, magnitude and calculate the magnitude and nature of the capital Q charge such that the net force experienced by the charge small q is 0. So what should be the value of capital Q such that the net force that is experienced by the small q charge is 0. So in that case, the value of capital Q should be positive because the net force is only possibly 0 only in the case where the charge small q is lying between the two charges. When is that possible? When you take this charge at A and this charge at B to be positive charges. Then only you will have the possibility of force acting on small q to be 0, because they are asking us to check what should be the capital Q value such that the small q will be experiencing the 0 force. That means the force on small q due to the charge at B and due to the charge at A should be equal in magnitude and opposite in direction. So for that case, what I take is, I take the capital Q value to be the value of capital Q to be positive, because as the same sign as of the small q and or small q, or you can take it as 4q, same sign as of the small q or 4q. So the forces Fa should be equal to the force Fb, the net here in this case. Then only they'll be equal in magnitude, opposite in direction, and cancels out. So that means what will be the force Fa here? Force Fa is equal to 1 by 4 pi epsilon naught into charge is 4q into q divided by the distance between the charges at A and C is x by 2 whole square, and Fb is equal to, we get it as 1 by 4 pi epsilon naught into the charges are q into capital Q divided by x by 2 whole square. This formula is from Coulomb's law, which is F is equal to the Coulomb's law formula. What we have? F is equal to 1 by 4 pi epsilon naught into q1 q2 by r square, the distance square. So using that relation only we write these two formulas. Now the force Fa 1 by 4 pi epsilon naught into 4q into q divided by x by 2 square is equal to 1 by 4 pi epsilon naught into q into capital Q divided by x by 2 square. Now cancelling out the 1 by 4 pi epsilon naught value, 1 by 4 pi epsilon naught value will get cancelled out. X by 2 square gets cancelled out. Here small q and q gets cancelled out. So what should be the value of capital Q? Capital Q should be equal to 4q. So that the force experienced by the charge at C, which is small q, will have a 0 force experienced on it. Hope you understood the question. Follow our channel for more such questions, and thank you.